You're tuned in to the Dish TV, the talk show from SRI International that highlights our people, products, and technology portfolio. This series will focus on the Quantum Economic Development Consortium, or QEDC, supported by the National Institute of Standards and Technology and managed by SRI International. The QEDC is a consortium of stakeholders that aims to enable and grow the U.S. quantum industry. I'm Renita Malhotra Hora, Head of Marketing and Communications. In this episode, my guest is Yanni Gambros, Head of Business Development at QCware, which develops enterprise software and services for quantum computing. I asked Yanni how quantum software and hardware are different from what we know of traditional computing and why QCware became a member of the QEDC.
I think the easiest way to explain it is that quantum is data science on steroids. So it's going to really change everything we do about data science, and it's going to change everything we do about hard computing problems. And that's why I'm excited. So my background is in advanced analytics, optimization, machine learning, predictive analytics in general. And I saw the opportunity of getting into quantum computing early, and I took it.
What is quantum computing? What is quantum software? And how do those two sort of fit together?
In any computing paradigm, you actually have hardware and you have software. At QCware, we're a software quantum computing company, and we concentrate on solving hard computing problems using quantum hardware. So we are on the software side, and actually when we say software, what we really mean is that we build quantum algorithms. So the internal workings of how you solve a problem on a quantum computer are actually very, very different than how you solve it on a classical computer. So that's the part that we do, that's the part that QCware does, and that's the part that we specialize on.
To the layperson, an algorithm is an algorithm. What is it about quantum, specifically quantum computing, that makes it different?
Yeah. So very good point. So the easiest way to explain it is the following. So classical approaches to solving a problem really follow a very specific path. So the algorithm basically states, okay, you do step one, you reach a solution. Maybe that's not the best solution. So you then go to step two, you make a choice, then you reach another solution, and so on and so forth. And you kind of exhaust the different paths and the different solutions that you are trying to explore, basically one at a time. So there's a very sequential nature to classical computing. That's actually not the case for quantum computing. So for quantum computing, actually it turns out that a quantum computer almost has a sense or a view of all solutions in your search space at the same time. Now, you still have to tell your algorithm how to characterize good solutions, how to understand which of these solutions are better than the others and promote those solutions. But that's a fundamental difference, that in classical computing, we're essentially sequentially going down a certain path and exploring solutions one at a time. Whereas in quantum computing, the computer actually is aware, is looking at all the search space, at all the solutions effectively at the same time.
So it sounds very much like the software development must be integrated with the hardware. Can you tell me what might be the biggest barriers to developing these technologies? Is it people who can translate from traditional computing to quantum computing? What would it be?
So the people that are experts in quantum computing algorithms, there are precious few people around in the world. We are seeing more and more people graduate from programs that have quantum computing expertise nowadays, but people that have been studying these problems for, let's say, 10 or even 20 years are actually very, very few. And there's just a very, very few of these people that have deep insights and deep expertise into these quantum algorithms. So that's one of the key barriers. The other technological barrier is the fact that our quantum computers right now are actually very, very small. So even though we as algorithm experts at QCware can build these amazing algorithms, we are actually still constrained by the very small quantum computers that are out there, and we can actually not demonstrate the power of quantum algorithms just yet.
Tell me, how did you come to know of QEDC and why did you decide to join?
Yeah, actually, we've known of QEDC for quite some time, since its early days, inception. Actually, we were at one of the first plenaries for QEDC, where the board was actually elected. And actually, it just so happens that our CEO, Matt Johnson, is sitting at the board of QEDC. And we immediately thought it was a great idea, because there's all these barriers, just like you mentioned, that might prevent quantum computing, or might make it harder for quantum technologies to actually be adopted in practice. Things like government policy, government funding, access to workforce, all of these things could potentially be barriers, standards that can prevent quantum computing from maturing sooner rather than later. And we saw it as an opportunity to kind of guide basically QEDC, and through QEDC guide some of these bigger questions around workforce development and standards, all these other things that I mentioned earlier.
Would there be specific industries that could benefit from quantum computing more than others or earlier than others?
Yeah, pretty much. You're right. Every industry that is now heavily using machine learning, heavily using data science, optimization, that's heavily using quantitative chemistry, will actually be impacted and will actually benefit from quantum computing. So we see some of the early adopters nowadays are companies that are in finance, companies that are in pharmaceuticals, in material design, automotive and aerospace, oil and gas, energy. So it's a pretty broad intersection of different industries that will be impacted.
You've had a few years already in the industry, and I'm curious, are there other industry collaborators that you have that you could talk about?
One of the companies that are actually very aggressive when it comes to industry collaborations, we've gone out to enterprises, industry leaders in some of the industries that we mentioned earlier. And we've now signed very successful collaborations. Actually, some of them have already been completed. Some of them are still in flight, but we've worked with the likes of Goldman Sachs in finance, Airbus in aerospace, BMW in automotive, and a few other customers in oil and gas.
Are you able to tell us at all about the kind of application you have developed for these clients and in these collaborations?
In aerospace, we looked at aircraft design. How can we ensure that aircraft design problems can be solved faster, can be simulated faster? How can we ensure that there are no issues caused by subsystems to some of the larger systems that aircrafts basically rely on? And for finance, for example, we looked at how we would do faster pricing of financial instruments like derivatives, for example. And in automotive, we looked at routing problems. How do you move a fleet of cars from one location to get to potential customers that are hailing, for example, cabs? And we also looked at use cases in manufacturing, where we looked at how can you execute manufacturing tasks faster and produce your final work product on time for orders that are coming in.
And what would you say is your outlook for QCware, let's say a year from now or 5 years from now?
Yeah, so I think a year from now, we're still going to be in this phase where we're basically going to be still making progress towards practical quantum applications without maybe having an implementation that's actually running on a quantum computer. But in 5 years from now, we do believe that with a few hundred qubits, we will be able to have some practical applications. There will probably be early applications, maybe just a handful of applications. It's not like we're going to be able to solve every computing problem out there on quantum computers. But yeah, in 5 years' time, we'll definitely have the just a handful of practical applications that people can use and start harnessing the power of quantum computers.